In the video before this, we talked about valence bond theory. We talked about how the Vesper theory and Lewis theory are oversimplifications because we're just thinking that two dots are coming together to form a bond. In valence bond theory, we went a little bit deeper into that scenario. We know that electrons exist in bonds, and electrons exist in orbitals, and in order for bonds to form, these orbitals overlap. Then we looked at how certain molecules exist in those geometries that we talked about. Linear, trigonal-planar, tetrahedral, trigonal-bipyramidal, and octahedral, all 5 basic electron geometries. Now, a lot of the atoms, because of the pairs in the s orbitals and unpairs in the p's, doesn't allow for those specific shapes to occur. Since those shapes are very, very stable, what happens is p and s and sometimes d orbitals come together and hybridize to allow for the correct arrangements of the orbitals and shapes to come together. Now let's practice that. Write the hybridization and bonding scheme, label all sigma and pi bonds for the following. So the best way to always start these is just to write out your Lewis structure so you can kind of visualize what's going on. Bromine trifluoride. All right, so I have Br with my 3, oopsies, it's not fluorine, fluorines around it. Wow, this is just not the best Lewis structure right now. Ah, that's a bond, ignore that electron. Boom, there we go. Fluorine, this is what happens when you go too fast. And then I have 2 lone pairs. Do I have 2 lone pairs? Let's see. Bromine has 7 valence electrons. Fluorine has 7 as well, but there's 3 of them. 3 times 7 is 21, plus another 7 is 28. Here I have 2, 4, 6, 8 times 3 is 24, 25, 26, 27, 28. Perfect. Now, bromine has 2, 4, 6, 8, 10 valence electrons. Is this allowed? Well, bromine is in period 4, so it has d orbitals and can expand its octet, so this is allowed. It's not allowed for fluorine because fluorine is in period 2. Perfect, so here I'm done. What is my shape of this? 2, 4, 6, 8. What am I doing? 1, 2, 3, 4, 5. 5 electron groups, so I'm trigonal bipyramidal, but I have 2 lone pairs, and then I have 2 bonds. So this is a T-shaped molecular geometry. Well, I know bromine has 7 valence electrons, and they're distributed through the orbitals. But because of different pairs, this will form a hybridization scheme. Now, what would be the hybridization of this? 1, 2, 3, 4, 5 electron groups is sp3d. A little trick I always like to say is I just start with S and start counting. So let's say S, P, 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 D. sp3d. So how do I show that in a drawing? So it wants to show you, we just wrote the hybridization, now bonding scheme. So I have my bromine, and I'm going to have an sp3d. So that means for my T-shaped trigonal bipyramidal, it'll look something like this. Here, and here, and here, here, here. So then my fluorine has its p orbitals that will overlap with the sp3d orbitals of each bromine. Great, there's my hybridization and bonding scheme. Now I can label each bond. Since it's exactly the same, I'm just going to label one because I know that they're the same for each one. So this sigma bond, because it's just a direct overlap, is from the bromine sp3d bonded to the fluorine f orbital, the p orbital of the fluorine. And this is the same for all of the bonds. Now let's look at this next one. Let's draw the Lewis structure first. I have 2 carbons. I know they can bond the most, so therefore I'm going to have 2 central atoms, carbon and carbon. Hydrogen around, hydrogen, hydrogen. This will bond to the carbon, and then the oxygen and hydrogen. The reason I had to bond twice to the oxygen instead of putting the hydrogen to the oxygen is because then carbon wouldn't have had 2 bonds here to give it 4 total. because I have two central atoms, I have two geometries. This is tetrahedral. This is trigonoplanar. So if I have two geometries, because I have two central atoms, do you think I would have two hybridizations? Yep. What's my hybridization? SPPP, SP3, SPP, SP2. Whenever you have a double bond, remember that means that there's a pi orbital, which means there's an unhybridized p orbital. So then let's draw this. Alrighty. So I have my carbon and I have my carbon, and let me do my sp3 orbitals. So I'd have one like this, and then close to there, and then here, and then I have my sp orbitals, sp2, here, here, and here. And then I have my hydrogens and my oxygen. So then my hydrogens, s orbital, will overlap here, and here, and here. And then my oxygen will have one p orbital that overlaps here, and then the other p orbital to give it a pi bond. So then if we want to label this, I have more this time. So here are my sigma bond for my carbon sp3 and my hydrogen s, right? That's for this one and that one. This is my sigma for carbon sp3 and carbon sp2. And here's my other sigma for carbon sp2 with hydrogen s. Then I have a sigma here with carbon sp2 and oxygen p. Then I have a pi bond with the carbon p orbital, the unhybridized, and the oxygen p orbital. And then you have your hybridization you stated, again, by drawing out the Lewis structure and then drawing out the bonding scheme, labeling all sigma and pi bonds. All right, let's try another one. Write the hybridization and bonding scheme for each molecule or ion. Sketch the structure, including the overlapping orbitals, and label all bonds. Okay, so another little practice. This time, let's include the atomic orbitals as well, so we can kind of see it a little bit better, what's going on. I'll be really specific on what I want on an exam, but let's do it for practice here. So let's say that this question asked also to include the atomic orbital arrangement. So let's first draw the Lewis structure to figure out my hybridization. Carbon, oxygen, chlorine, chlorine. This is trigonoplanar, so sp2. spp, sp2. Awesome. So my central atom is carbon. I know I have 2s and then 2p. So here again, you can visualize that these had to hybridize to form your sp2 and the unhybridized p orbital. So that's all where that's coming from, just a little recap of where this is all happening. So let's draw that structure. So I have my carbon, oxygen, chlorine, and chlorine. And then I have my sp orbitals to give me my sp2 to give me my trigonoplanar shape. So they're all 120 degrees away from each other. Then I have my p orbitals of my chlorine, my oxygen, and my other chlorine. And then, because I have my one unhybridized, I know that I form a pi bond with the oxygen. And then we label. Sigma with carbon sp2 and chlorine p, and that's the same for both of these. Then sigma with carbon sp2 and oxygen p, and then pi with carbon p orbital unhybridized and oxygen p orbital. Alrighty, so now that we've done all of that together, the hybridization, the bonding scheme, we sketched the structure and included the overlaps, and we even showed the atomic overlapping of where everything comes from when they hybridize, and we labeled all bonds. Now I want you to try for the engagement of this part of the lecture to try this ion, knowing that this is an extra electron, and see what happens to that hybridization in the bonding scheme with this structure.